Hey makers, today we're going big with the ESP32. Imagine controlling a servo position, turning LEDs on and off, running LED animation, and even typing text that shows up on live OLED screen, all from a single web app. Oh, and we'll also track real-time physical button in real time so that the status updates instantly on web pages. This is ultimate ESP32 web demo packed with everything you'll love in one project. Let's dive in. For this project, you'll need a few components: an ESP32, a breadboard, a physical button which looks like this one, an OLED screen, and a servo motor, and finally an LED with the 220 ohms resistor. In this circuit, I'm connecting the button pin to pin 12 of the ESP32. Then I'm connecting the LED pin to pin 14 of the ESP32. And finally, I'm connecting the servo pin to pin 13 of the ESP32. Now we're going to program the ESP32 so that when we upload the code, the web server starts and the three components can be controlled, which is the servo, the button, and the LED. We need two libraries: the Wi-Fi library. Next, we need the ESP32 servo library. Then we need three variables which will store the corresponding components pin, which is servo pin, button pin, and LED pin. Next, we need two variables: button pressed and LED status. Both of them become true when I press the physical button and the toggle LED button in the web server. Next, we need two variables that stores the Wi-Fi credentials. Next, we need to make the HTML, CSS, and JavaScript for the web server to start up when we upload the code. Then in the void setup, we have to start the servo, and then we need to make the button pin and LED pin as output and button pin as input. And we also make the LED pin, which is the LED, to be low, which means off. And then the Wi-Fi starts, and it will give the Wi-Fi credentials, not the Wi-Fi credentials, the IP address, which we will use to start the web server. Then in the void loop, what will happen is the web server will send a response to the code. And once the response is sent to the code, it will send to the ESP32. Oh, the button has pressed. So now in the web server, it will say button has pressed in the status. And then once I release it, it'll say not pressed. Same thing for the LED. When I press toggle LED, then the LED will turn on. How? By this void loop function. Now that we have programmed the ESP32 and uploaded the code, the web server has started. It says ESP32 Web Control Panel. Then we have three things: server control, button status, LED control. When I press toggle LED, status changes to on and the LED is flashing. When I press toggle LED, status changes to off and the LED is not blinking anymore. And then we have button status, status not pressed. And when I press it, it changes to pressed. When I release it, it says not pressed. Now we have the servo control and angle is 0. Now I'm going to put it at 180. We can see that the servo is moving. And now when I put it back at 0, the servo moved to angle 0. Now I'm moving it slowly. And now if I put it at 131, it changes. Now when I put it back at 221, it changes. In this circuit, I'm connecting the OLED screen to the ESP32. The GND pin of the OLED screen is going to GND of the ESP32. The VCC pin of the OLED screen is going to 3.3 volts of the ESP32. The SCO pin is going to GPI22 of the ESP32. The SDA is going to pin 21 of the ESP32. Now we need to program the ESP32. We need few libraries: the Wi-Fi library, the async TCP library, ESP32, async web server library, Adafruit GFX, and Adafruit SSD 1306. These two libraries, the GFX and the SSD 1306, is meant for the OLED screen to display the text that is coming in from the web server. Next, we need to set up our Wi-Fi credentials, and then we need to set the screen width and the screen height of the OLED screen. Next, we need to program the HTML and the CSS for the web server, which is right here. And then in the web setup, we have to start the OLED screen. So we have few things like display, the clear display, and it's saying starting here, which means the display will start saying starting. And then once we type the message and press send, it will start sending that message to the OLED screen and it will display, which I'll show you in a few moments. Now that we have programmed the ESP32 and we have uploaded the code, it started the web server called send message to OLED. Now if you go into this type your message text box, I can type any message and it will display on this OLED screen. I'm going to type hello, and then if I press send, it should send. And now it says hello. And then if I put subscribe on this text box and press send, it says subscribe, which you should do. And now I'm going to put like and comment. And when I press send, it says like and comment, which you should do. In this circuit, I'm connecting 5 LEDs: the red LED, the blue LED, the yellow LED, the green LED, and a color changing LED. Each LED is connected to G and D of the ESP32. Each LED is connected to one separate GPIO pin. The first LED is connected to 13, second one is 12, third one is 14, fourth one is 27, and fifth one is 26. Now I'm going to program the ESP32. We have to have few libraries, which is the Wi-Fi library and the web server library. Then we need to make two variables for our Wi-Fi credentials. Then we need to make one variable that stores all 5 LEDs pin. Then in the white setup, we can start setting up those LED pins one by one in a for loop. And then we can start the Wi-Fi, which will give our IP address once the ESP32 has connected to the Wi-Fi. Next, in the handle root, which is the code where we have the HTML code so that the web server can use that. And then we have run animations. When each animation is clicked, then the ESP32 will get a command from the code which tells, okay, this animation has been clicked and now this animation needs to start. And then all the 5 LEDs will do its job, which is the animation. Now that we have programmed the ESP32 and uploaded the LED animation program to the ESP32, we can see that it says select an LED animation. There are few of them we can choose from. Blink all means every single LED, all 5 of them will blink. Chase means it will go one by one but chasing one after another. Ping pong means it will act like a ping pong table but with the 5 LEDs. One by one means one at a time it will blink and go after one another. All flash means all 5 LEDs will flash at the same time. How cool is this? And there you have it, one ESP32 project that does it all: servo control, LED animations, OLED text, and live button status, all from a simple web app. If you enjoyed this project, smash the like button, subscribe for more ESP32 and IoT builds, and drop a comment telling me what features you'll add next. Until next time, keep making, keep coding, and see you in the next build. Peace out.